third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live.
What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
The image arrives suddenly in the silent files transmitted from the Martian surface, almost like a message in a bottle cast across the gulf of space. It was faint, a thin streak of light, a pale, elongated smudge cutting against the dark Martian sky as seen by the Perseverance rover. But the timing could not be ignored. It aligned precisely with predictions for the Interstellar Visitor 3 1 Atlas crossing near Mars. Scientists stared at that strange stripe with equal parts exhilaration and dread, and realized the implications could be far greater than anyone had anticipated. Before we start, smash the like and subscribe buttons for more updates. At first glance, the elongated form seems almost unnatural. A long line, roughly 4 times as long as it is wide, hovering across the frame. But to claim that it was a gigantic alien cylinder would be to leap ahead of the data. Instead, the image embodies a crossroads, raw observation colliding with cosmic mystery and the discipline of scientific caution pressed up against the lure of the unknown. For days now, radio silence from NASA's announcement offices has only fueled fevered speculation. The world watches and waits, and scientists whisper in corridors, unsettled. Because if this streak really is 3I Atlas, what we are glimpsing might challenge how we understand interstellar visitors, and perhaps even our assumptions about the loneliness of our place in the cosmos. The context is critical. 3I Atlas is the third confirmed interstellar object traversing our solar neighborhood, an object not bound to the sun but passing through on a hyperbolic trajectory. Astronomers first spotted it in July 2025 via the Atlas survey in Chile. Already it had attracted attention. Its path, speed, and brightness were all tantalizing anomalies. Now, as it drifts past Mars, one of our most capable emissaries to another world may have captured its image, and the consequences are profound. In the night sky above the red sands, the rover's right navigation camera, NavCam, recorded that curious stripe during a long imaging interval on October 4th, 2025. At that moment, 3I Atlas was estimated to lie tens of millions of kilometers away from Mars, a distance enormous yet not insurmountable in astronomical scales. The elongated shape of the observed mark, however, is far too extended to be the comet's true physical form. When calculations are carried out, the projected stripe spans some 50,000 kilometers in apparent length, vastly larger than any plausible physical dimensions for 3I Atlas, whose nucleus is thought to be tens of kilometers at most. Thus, the prevailing interpretation is that the observation is an artifact, an effect of long integration time, of the object sweeping slowly across the field of view during the exposure. Still, that explanation leaves room for dread. If the image is real, if the strip corresponds to 3I Atlas's shimmer across the Martian sky, then we have something unprecedented, a direct surface-based sighting of an interstellar wanderer using instrumentation on another planet. To imagine this blurry streak as simply a distorted blob or a diluted version of the comet's glow still doesn't erase the vertigo of knowing we might be watching the passage of something that came from beyond our solar system. In the broader scientific community, the balance tilts between excitement and caution. Many researchers emphasize that the cylindrical shape is almost certainly a technical artifact, not a literal shape. Avi Loeb, who has often stirred debates with bold speculation, lays out the mathematical limits of the imaging system, arguing convincingly that the elongated form must be a time-stretching effect. The movement of the object during the composite exposure smeared it across the image plane. Others echo this reasoning, pointing out that if one took each individual short exposure snapshot, the object would appear as a small, bright dot, not a rod-like figure. The banding, then, is a signature of motion, not morphology. Yet even as astronomers argue over image processing, a deeper tremor resounds. What if 3I Atlas is not a conventional comet at all? The more data we gather, the more this object defies simple categorization. Spectroscopic observations already reveal a coma dominated by carbon dioxide with only minimal amounts of water, a very unusual ratio for a comet in this part of space. The CO2 H2O mixing ratio is exceptionally high, among the highest ever seen in cometary bodies. Water activity itself has been confirmed via ultraviolet emission of hydroxyl radicals, implying active sublimation even at large distances. Meanwhile, the polarization measurements of its coma behavior show a negative polarization signature unlike typical comets or asteroids, deep, narrow, and suggestive of a dust composition unlike what we've seen before. Combining these strange clues, some theorists suggest 3I Atlas may embody a different class of interstellar object. Neither pure comet nor inert rock, but something rarer, perhaps even manufactured. When the rover's image was first revealed, social media erupted. Enthusiasts and amateur surveyors combed through raw rover image sets, stacking frames and searching faint smudges near constellation alignments. Some produced time-lapse sequences showing a light traveling across the sky at high speed, claiming confirmation of the comet's path. One user stacked 9 minutes of images from October 2nd and reported seeing an object moving supersonically relative to the Martian rotation. Others flagged the faint smudge in Corona Borealis, matching predictions for where 3I Atlas should be. But skeptics quickly countered that the smear could be an artifact of Phobos' motion, or stray cosmic rays, or simply imaging noise. The debate became a microcosm of modern astrophysics, raw data, public scrutiny, and the constant dance between hopeful interpretation and strict methodology. Behind the excitement, though, lies an elemental fear. For centuries, humans have searched for signs of extraterrestrial life. The detection of a craft, or even the suggestion of one, would represent a paradigm shift. We would be forced to reconsider how we search, how we interpret, and how we assign probabilities to the presence of intelligence beyond Earth. The thought that a rover on Mars might snap the first surface-based image of an interstellar voyager, possibly even an artifact of intelligence, has left some scientists unnerved. The moment is not just scientific, but philosophical. It forces us to confront the possibility that we are not alone, and that our methods of seeing and reasoning might be inadequate. Yet in the halls of NASA and in the quiet chambers of university labs, caution still reigns. Scientists emphasize that extraordinary claims require extraordinary evidence. Right now, what exists is a single streak in a NavCam image filtered by long exposures and subject to all manner of distortion. It would be reckless to claim more. Instead, experts are calling for coordinated observation from every vantage possible. Mars orbiters, ground telescopes, and possibly even other spacecraft are being instructed to target 3Y Atlas in the coming weeks. Additional imaging, spectrometry, polarization data, all must converge before any bold statements can be made. In the meantime, the image lingers. That single stripe is like the trailing brushstroke of something immense sweeping past Mars at unimaginable speed. It is both an indicator and a question. It tells us that 3I Atlas was in the right place at the right moment to be seen from another planet, and it tells us that our imaging systems are working at their limits, stretched by distance, sensitivity, and time. We are witnessing the frontier of observational astrophysics, where the margin between signal and noise is vanishingly thin. Consider also how this changes our view of Mars itself. The rover that trekked across dusty plains and drilled into ancient rock is now serving as an interstellar observatory. The red planet, once relegated to our geological curiosity, has become a platform from which we peer outward, into the depths beyond our solar boundaries. The rover's mast and lens, once intended to study minerals and traces of past life, may now be tools to record the passage of something older than our solar system. This is a profound transformation of purpose, one that connects Mars missions to cosmic exploration in real time. Every image frame, every calibration curve, every bit of telemetry takes on new weight. The engineers who calibrate NavCam exposure times must reconsider the subtle effects of motion blur across interplanetary distances. The scientists who model the comet's trajectory must integrate cross-planet viewpoints. Earth-based telescopes, Mars-based imaging, orbital sensors, all triangulating the same visitor. The challenge is immense, and the stakes are high. In the quiet hours, some night shift controllers wonder, what if the smudge reveals something unexpected? What if there is structure, geometry, or artificial features hidden under better imaging? What if the comet is not merely a frozen relic, but a sentinel or probe, These are speculative notions, yet they haunt the imagination. Already, theorists are drafting papers on the implications of an extraterrestrial hard artifact passing through the solar system. They explore how its trajectory might be purposeful, how its outgassing might be engineered, and how such an object might seek to observe or even interact with planets it passes. Yet even as those possibilities gather in dark corners, the scientific ethos demands caution. Analysts dissect the imaging metadata, exposure time, stacking algorithms, pixel sensitivity, motion vectors. They run models to show how object motion during integration smears a point into a line. They simulate alternate explanations, cosmic rays, sensor glitches, the faint motion of Phobos behind the rover. They challenge each other in peer review, insisting on rigor before revelation. The fear is not of being wrong, the fear is of jumping too far too soon and so tainting the credibility of discovery. So for now, the image remains a provocative prompt rather than a proof. But it is enough to shift perspectives. It forces us to think, if an interstellar object can be seen from Mars, what else might we detect if only our instruments were better? It suggests that the cosmic sea may be laced with such wanderers, and that some may pass close enough to be seen from multiple vantage points. It forces a reconsideration of probe design, imaging strategies, and the need for more eyes beyond Earth. For Mars lovers, the moment is electric. The rover, so long a symbol of planetary exploration, now participates in celestial surveillance. The Martian surface becomes a vantage point for humanity's gaze outward. Every day of observation becomes a potential cosmic encounter, not just a geological mission. And for terrestrial astronomers, the implications ripple outward. This possible Mars-based detection offers a new cross-check on Earth-based observations. It strengthens our triangulation power. An object seen from two planets simultaneously allows far superior precision in trajectory and velocity determination. If 3I Atlas is indeed seen from both Mars and Earth, we can refine its orbit with unprecedented accuracy. This may be our best chance ever to fully characterize an interstellar traveler before it vanishes back into deep space. Yet the dread remains. What if 3I Atlas is more than a dusty relic? What if, behind its shimmering coma, lies a structure, an intelligence, or a message? The fear is not necessarily of invasion, but of surprise, of encountering something utterly foreign that challenges our understanding of physics, biology, or intention. The boundary between natural and artificial may not be clear. If one day it becomes evident that 3I Atlas is engineered, we would enter a new epoch of cosmic relations. But today we remain in the threshold. That single smear across the Martian sky stands as a bridge between the known and the possible. It says, we have the capacity to witness interstellar strangers not just from Earth but across worlds. It says, our technological reach now extends into the flow of the galaxy. And it says, we should be humble, poised, and ready, but not reckless. The faint streak caught by the Mars rover's camera did more than capture light. It captured a moment in time that may redefine humanity's relationship with the cosmos. Within NASA's control rooms, as the raw data streamed in from millions of miles away, a hush fell that no mission transcript could ever convey. Scientists leaned closer to the monitor, transfixed not only by what they saw, but by the implications that hung in the silence between frames. There it was, 3I Atlas, passing like a whisper of eternity above a world that itself once might have harbored life. To grasp the weight of that instant, one must first imagine the setting on Mars. The thin atmosphere lets the stars burn far brighter than they do from Earth. Every pinprick of light in that violet-black sky is clear, unshrouded by air or weather. Against this backdrop, the streak cut across the heavens like a blade of luminescence. The rover, still and obedient, captured its faint passage automatically, unaware that this singular exposure would ignite feverish debate across the scientific world. The image was sent to orbiters, then relayed to the Deep Space Network. It arrived at NASA's Jet Propulsion Laboratory around dawn Pacific time. What the image contained could not have been anticipated, not a geological oddity or meteorological marvel, but an interstellar visitor crossing the Martian night. The first hours after the discovery were a blur of activity. Teams rushed to confirm the coordinates and orientation of the rover at the time of capture. They recalculated exposure intervals, sensor gains, and stellar references to ensure the streak was not an artifact of internal reflection. Nothing matched any previously cataloged pattern. The navcam's telemetry was clean, its optics stable, and the timing coincided precisely with the projected trajectory of 3Y Atlas as it passed near Mars. Every technical explanation ruled out only deepened the strangeness. The realization dawned slowly but inexorably. The rover had genuinely witnessed an interstellar body from the surface of another planet. Though astronomers had tracked such objects from Earth before, Oumuamua and 2I/Borisov being earlier examples, this was different. This was not a ground telescope peering through Earth's haze or a fleeting satellite measurement. This was a machine built by human hands, resting on alien soil, looking outward from an entirely different world. The perspective alone was staggering. It meant humanity had effectively extended its senses into interplanetary space in a way that no prior mission had achieved. The simple act of detection symbolized the expansion of our awareness beyond Earth's orbit, a literal new point of cosmic observation. In conference rooms and mission control centers, specialists convened around digital projections of the streak. Some marveled at its clarity, others fixated on its length. For astrophysicists, each pixel in the frame was precious, a unit of potential discovery. For engineers, it was a validation of precision mechanics operating perfectly under hostile conditions. And for the philosophers quietly observing from the sidelines, it was a vision that stirred existential unease. For the first time, a human-built machine on another planet had looked up and seen something not of our solar system, a messenger from interstellar space reflected in a Martian sky. The analysis unfolded in layers. Teams at NASA's Image Processing Laboratory dissected the frame's photon counts, seeking faint gradients along the streak. They noticed slight oscillations in brightness, regular enough to suggest that as 3I Atlas moved across the field, the intensity of reflected sunlight varied rhythmically. Was it simply rotation, a tumbling rock shedding gas and dust as it spun? Or was it an irregular reflection pattern hinting at facets or structure? The question hovered uncomfortably, unspoken yet felt by everyone studying the image. At the same time, orbiters around Mars adjusted their instruments to verify the event. The Mars Reconnaissance Orbiter's HiRISE camera, designed for ultra-high-resolution imaging of the surface, was repurposed temporarily to scan the upper atmosphere. Even though the chance of capturing 3I Atlas was slim, scientists could not resist the opportunity. The trace gas orbiter attempted spectroscopic analysis of the Martian sky, searching for transient emissions of CO2 or CN, the typical signatures of a cometary coma. Every possible sensor was brought to bear. This was not just another observation. It was a cosmic alignment of opportunity, the right object at the right time above a planet perfectly equipped to see it. As the data accumulated, patterns began to emerge. The object's brightness did not remain constant. It fluctuated subtly but consistently over several hours. The variations seemed too regular to be random noise, suggesting rotation or pulsation. On Earth, large observatories from Hawaii to Chile synchronized their efforts with the Mars observations, comparing light curves. The rhythm was identical, a slow, deliberate modulation every 8.3 hours. That rotation period might have seemed benign, but the amplitude of the brightness change implied an elongated body, perhaps cigar-shaped, similar to Oumuamua. Yet 3I Atlas appeared more volatile, emitting bursts of gas with unusual spectral fingerprints. Back on Mars, the rover's imaging queue was altered to dedicate additional observation windows. Engineers faced a dilemma. The rover's primary mission was to study geology, not astronomy. Every second spent tracking the comet reduced its limited power reserves. But the chance to capture more data from an interstellar traveler was irresistible. Mission Control authorized a series of long-exposure sky captures over several sols. The rover tilted its mast and adjusted filters, scanning the same region repeatedly. Each night, faint trails appeared, sometimes single, sometimes branching, as if the coma were shifting direction. One night, the camera recorded something that made even the most stoic analysts pause. Amid the faint line of 3I Atlas, there was a sudden bright pulse, a flare that lasted less than a second, then faded. It was unlike the gradual intensifications caused by outgassing. This was abrupt, sharp, and spectrally pure. The explanation could be a reflection, perhaps a glint of sunlight off an icy jet, or even the angle between the rover, the comet, and the sun aligning momentarily. But in the human mind, more evocative possibilities took root. Could it have been a directed reflection, a glint from an unusually reflective surface? The idea was too premature to state aloud, yet the speculation simmered under the surface of professional restraint. As researchers debated, modelers ran simulations of the object's possible shape and composition. The unusual gas ratios measured earlier from Earth-based telescopes suggested a volatile mix, unlike typical solar system comets. Its relative depletion in water ice but abundance in carbon dioxide hinted that it formed in a region of intense radiation, perhaps the outer mantle of another star's system, or within the boundary zones of a dying protoplanetary disk. If so, its journey to our solar system could have begun billions of years ago, ejected by gravitational chaos from its parent system and wandering the void ever since. The thought of that timescale staggered even the most seasoned astronomers. A traveler older than human civilization, older than Earth's continents as we know them, had just been seen by a machine on Mars. The discussions turned speculative. Could 3I Atlas carry trapped particles, isotopes, or microorganisms unique to its home system? If so, it represented a scientific treasure, a chance to study extraterrestrial chemistry untouched by our solar processes. Even the dust trailing behind it could hold the secrets of alien planetary formation. Unfortunately, Mars's thin atmosphere and the rover's limited capacity meant no sample collection was possible. All humanity could do was observe. Yet that act of watching from two worlds at once created a bridge of data spanning millions of kilometers. Inside the Planetary Science Division at NASA headquarters, an air of restrained tension persisted. The official communications team was instructed to avoid sensational language, but the story was already spreading. The leaked raw images had been downloaded by amateur astronomers who overlaid the streak with known star fields, confirming the alignment with 3I Atlas's trajectory. Online forums filled with speculation, and soon the phrase "alien visitor over Mars" began trending worldwide. NASA's Public Affairs Department faced an impossible balancing act: to acknowledge the wonder of the image without fueling hysteria. The internal reaction among scientists, however, was complex. Beneath the professional language of reports and memos, there was genuine awe, even fear. The fear did not stem from the object itself, but from the magnitude of what it implied. Each interstellar visitor forces a reconsideration of how dynamic the galaxy truly is. The cosmos is not static. It is alive with motion, debris, and possibility. The realization that pieces of other systems regularly pass through ours makes the idea of interstellar communication or contamination less hypothetical. It raises questions about panspermia, about the exchange of materials and potentially life between stars. It suggests that the seeds of biology might not be bound to one sun alone. In private moments, some scientists confessed a sense of insignificance. Looking at that faint streak, they felt the vertigo of perspective. A visitor from elsewhere gliding past a world we are only beginning to explore, unnoticed except by a handful of machines. The universe, they realized, does not revolve around our curiosity. It simply moves, indifferent, majestic, and silent. The terror was existential, not physical, a confrontation with cosmic humility. Meanwhile, every fresh image from the rover deepened the mystery. As 3I Atlas moved closer to perihelion, the point of its nearest approach to the sun, its coma brightened dramatically. Yet the spectral data revealed inconsistencies. The dust grains appeared unusually large, and their reflectivity did not match common carbonaceous or silicate compositions. Some suggested metallic inclusions, minute particles that glittered in sunlight differently than expected. These anomalies could easily have natural explanations, but they unsettled researchers nonetheless. Nature, after all, does not often surprise in so many directions at once. As observation continued, the trajectory analysis refined itself. The comet's hyperbolic excess velocity, the speed it carried even after escaping solar gravity, was measured at nearly 60 kilometers per second, faster than any known solar system comet. The implication was that it had been traveling through interstellar space for millions of years, untouched by any star's gravity. And yet, curiously, its path had aligned to pass close not only to Earth's orbital plane, but now Mars's as well. Statistically, this was improbable. To some, it was coincidence. To others, an alignment worth deeper thought. Among theorists, new hypotheses arose. What if interstellar objects like 3I Atlas are more common than we assumed, constantly drifting through the solar system but invisible to us because of limited observation? The idea transformed from speculation to probability as detection capabilities improved. If so, then our solar system might not be isolated at all. It could be a crossroad of interstellar debris, a cosmic thoroughfare where remnants of countless worlds intersect. In that sense, 3I Atlas was not an anomaly but a harbinger of what future telescopes will reveal in abundance. Yet for all the scientific promise, an unease persisted. The thought that we were being watched or that something alien might traverse our space so freely stirred primal instincts. The terror scientists felt was not of monsters or invaders, but of discovery itself, of the sudden widening of reality beyond comprehension. Each new data point added a layer of wonder but also chipped away at the comforting illusion that humanity stood at the center of understanding. At the same time, the Mars Rover, blissfully indifferent to human emotion, continued its routines. It swept its mechanical arm over rocks, drilled into ancient sediments, analyzed spectra, and then lifted its mass to the heavens again. The little machine became a poet of the cosmos, its metal eye capturing both the history of Mars beneath its wheels and the future of interstellar exploration above its head. Engineers on Earth could almost imagine it pausing, gazing, as though aware of the cosmic theater unfolding overhead. When the next transmission arrived, it included something new. A faint halo pattern around the streak, barely visible but measurable. The halo's asymmetry suggested the object's outgassing was directional, perhaps jetting more strongly on one side than the other. That too could account for its erratic acceleration. Another similarity it shared with Oumuamua, which famously sped up as if pushed by invisible thrust. The scientific explanations, outgassing, asymmetrical emission, radiation pressure, remained plausible. Yet somewhere beneath the layers of logic lay that stubborn whisper of wonder. What if it was not a natural acceleration? What if the jet was controlled? The psychological impact of such thoughts cannot be overstated. For centuries, humanity has sought proof that we are not alone. Yet the moment such proof even hints at revealing itself, the response is not triumph, but fear. Fear of what it might mean for our beliefs, our history, and our sense of place. Fear that intelligence far older than ours might exist, indifferent to our existence. And perhaps most haunting of all, fear that we might never know for sure. Weeks passed, and the comet's trajectory carried it steadily inward, drawing closer to the sun's heat. Its activity increased dramatically, the coma expanding until it became a faint but visible spectacle in Earth's telescopes. From Mars, the streak brightened until it appeared not as a thin line, but as a luminous fan stretching across the horizon. For the rover's camera, it was too bright to resolve fine detail. Each new exposure washed the sky in a ghostly haze. The rover's imaging system began to experience brief data anomalies during these high luminosity captures, packets of static, momentary loss of signal coherence. Engineers traced it to electromagnetic interference from solar activity, but some wondered whether the intense cosmic radiation from the comet's ion tail contributed. Mars's magnetic field is weak, and its surface electronics vulnerable. Whatever the cause, the interference lent an eerie edge to the mission logs. Lines of corrupted data scrolled across screens at mission control, like cryptic code from a distant source. It was a reminder of how fragile our connection to these remote explorers truly is. Amid the growing tension, a curious shift occurred among planetary scientists. Rather than merely analyzing the event, they began reflecting on its philosophical significance. Mars had become a witness to the universe, a platform where humanity's mechanical emissary could observe something alien. This inversion of perspective was profound. Usually, Mars was the object of observation, the mystery to be studied. Now it was the observer, the eye through which we glimpsed something beyond ourselves. The realization filled researchers with pride but also unease. The boundary between observer and observed, between subject and cosmos, had blurred. The public's fascination only intensified. Artists rendered digital interpretations of what 3I Atlas might look like up close, gleaming shards tumbling through starlight, fractured surfaces glinting like metal, jets of ice casting veils of vapor into space. Speculative documentaries appeared overnight hinting at alien technology or cosmic messengers. NASA, ever cautious, released calibrated data with detailed explanations, emphasizing that no evidence supported such claims. Yet the human imagination cannot be constrained by data tables. The image from Mars had already transcended science. It had become a symbol, a modern myth of cosmic encounter. Inside research facilities, more sober efforts continued. Teams used parallax measurements between Earth and Mars to refine the object's trajectory to within a few hundred kilometers. That precision allowed them to model its origin path backward through the Milky Way. The result pointed to a faint, ancient stellar association roughly 300 light-years away, a region known for its volatile debris belts. If that were indeed the birthplace of 3 Amai Atlas, then the object had traveled across the galaxy for tens of millions of years before this brief intersection with our solar system. The magnitude of that journey dwarfed any human timeline. In that sense, the terror scientists felt was not just existential but temporal. The confrontation with time on a scale that renders civilization itself microscopic. When the data from the final series of exposures arrived, the object was already receding from Mars's view. The streak grew fainter each night until it disappeared entirely into the glare of the inner solar system. For the rover, the event was over. Its cameras turned once more to the ground, to the silent dust and the ancient riverbeds that hinted at Mars's lost oceans. But for those who had seen the image, the moment lingered like an echo that would not fade. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA's Mars rover capturing 3I Atlas? We want to hear from you. Thank you for watching and see you next time.